Hi everyone, welcome back to Math Hub by Mr. H. And in this video, you will learn about geometric sequences. But before we move on to the very first example, I would like to take this opportunity to thank you all for supporting my YouTube channel. And please, if you haven't subscribed yet to my channel, please do so and help me recommend this channel to students who need support in improving their math skills. All right, let's take a look at the very first example. Example 1. Given the sequence, letter A, find the common ratio, and letter B, find the 20th term. All right, so let's answer question 1A. Find the common ratio of the given geometric sequence. All right, so first of all, common ratio is represented by R. And in order to find the common ratio, we need to pick any term in the sequence divided by the term before that. All right, so to find R, we take -40 divided by the number before -40, which is 10. So that gives us -4. All right. So the common ratio of this sequence is -4. All right, so let's also check for the other pairs. Let's see if the value of R is consistent. So the next pair will have 160 divided by the number before that, which is -40. So 160 divided by -40 is -4, same value. And for the last pair, we'll have -640 divided by 160. That is also -4, right? So you can see that the value of R, or the common ratio, is consistent for all the pairs. So definitely it's a geometric sequence. Therefore, the common ratio is -4. Right, that's the answer for 1A. And we move on to question 1B. So we are asked to find the 20th term. And for this question, we will be applying this formula. A sub n equals A sub 1 times R to the power of n minus 1. All right, so A sub n is the nth term. A sub 1 is the first term of the given sequence, which is 10. R is the common ratio, which we already found in question 1A. And n is the term position. All right. Since 1B is asking us to find the 20th term, so definitely our A sub n will be A sub 20. So we substitute the value of A sub 1, the first term of the given sequence, is 10 times R is -4 to the power of n is 20 because that's the term position that we're looking for, minus 1. And then we simplify the right hand side. So A sub 20 equals 10 times -4 to the power of 20 minus 1 is 19. All right, so we need to get the value of this. All right, so A sub 20 is equal to very large negative number. So it's -2, and then you have 748, 779, 069. Wow, it's a very large negative number. So that is the answer to 1B. All right, so if you find this question interesting, please give me a thumbs up, and let's head on to our second example. For example number 2, we need to consider the given sequence. And for question A, it says when x is equal to -3, The sequence is geometric. What are the first three terms? So basically for question 2a, what we need to do is to substitute the given value of x, which is -3, to each expression here. All right, so let me write the answer here. So for the first term, so -5 minus -3. Second term is 7 times -3 plus 17. And the third term will have -3 minus 5. Let's simplify each expression. So we'll have -5 minus -3 is -2. Second term will have, so 7 times -3 is -21 plus 17, that is -4. And the third term is -3 minus 5 is -8. Those are the first three terms. In question 2a, it's mentioned that it's geometric when x is equal to -3. So let's try to check for the common ratio if it's really consistent. To find the common ratio, we take -4 divided by -2, that is equal to 2. So for the next pair, let's see, -8 divided by -4 is +2. So the value of r here is +2. So consistent. All right, so that's really geometric. Rewrite the answer for letter A. Well, let's head on to question 2b. Other than -3, what value of x makes the sequence geometric? So for this question, we need to use the concept of how to find the common ratio, which we already did in question 1. And we actually just did when we checked the common ratio for the first three terms, right? So we know that to find the common ratio, we need to pick any term, right? But we need to divide that term by the number before that. So we're going to be using the original sequence given, where each term is represented by algebraic expression. So for the first one, we take 7x plus 17 divided by the first term. And the other pair, because we need to establish, or we need to set up an equation here, which is coming from the concept of finding the common ratio. So the next pair will be this term divided by the term before that. So this is the equation that we need. All right, and from here, you can see we can apply cross multiplication. So we'll have 7x plus 17 times 7x plus 17 equals, so this 2. All right, so for the left hand side of the equation, we can actually rewrite that into 7x plus 17 to the power of 2. Okay, this part right here, we can factor this out, take -1 out from that. That's for this one. And we simply copy this. So I did this because by observation, we can actually apply special products. If you haven't watched the previous video I uploaded about special products, so I will link that to this video so you can check the description box later. This one on the left hand side, so to get the product of that, so first we take the first term and square it. All right, so next we copy the sign here, that's positive, and we will copy that to the middle term of the product. Next, we take the first term times the second term and multiply it by 2. So 2 is fixed. And then the sign of the third term is always positive. And to find the last term, we take 17 squared, 289. equals -1. The product of these two, difference of two squares. So we just take x times x is x squared. And the sign is always negative in the middle. And 5 times 5 is 25. All right, and then we simplify from here. So we have 49x squared, 238x, plus 289 equals -x squared plus 25. Then we combine like terms from here. So 49x squared plus x squared. Then we copy 238x. We copy 289, -25 here on the left equals 0. So 49x squared plus x squared is 50x squared plus 238x, 264 equals 0. Alright guys, so this is quadratic. Completing the square and factorization, they are not the smart options for this one because the numbers are really large. So we will go for quadratic formula. All right, so if you need a refresher about quadratic formula, you can also check out the link in the description box. The numerical coefficients and even the constant term are all divisible by 2. So we can divide all of them by 2 to make the numbers smaller. All right, so the numbers are smaller now. And maybe you're wondering, so even if you use the original one or the reduced one, you will still get the same answer. All right, you're just making life easier with the second one because the numbers are smaller. All right, so let's apply the quadratic formula here. And we'll have here the value of A. So B is 119 and C is 132. I'm going to be writing the solution here on the right hand side. So quadratic formula will have x equals -b plus minus square root of the discriminant, which is b squared minus 4ac, divided by 2a. And then we simply substitute the values. And then we simplify everything. So -119 plus minus square root of this whole thing right here, 961 divided by 50. For the first value, we'll have x equals -119 plus square root of 961 divided by 50, which is -44 over 25. And for the next value, this must be -3. So -119 minus square root of 961 divided by 50. So we just separated the plus minus over here. Good. Yeah, it's -3, which was already mentioned in question number 2a, right? Therefore, the answer that we're looking for is this one. All right, so let's have a quick recap of what we have done. The formula for geometric sequence is a sub n equals a times r to the power of n minus 1, where a sub n is the nth term, a or a sub 1 will be the first term, r is the common ratio, and n is the position of the term. And the second one, to find the common ratio or r of a geometric sequence, we need to divide any term in the sequence by the term that precedes it, which is also represented by this formula. So I hope that you learned something new from this video tutorial, and thank you very much for staying until the end of this video. And if you think that this video is helpful, please give me a thumbs up, share the video, And if you haven't subscribed yet to my channel, please do so. And once again, this is Mr. H, and I will see you in the next video.